Good afternoon, everybody. For those of you who don't know about Happiest Minds, it is not a charity organization. It's a for-profit consulting company in product engineering space, actually. And I represent the data center technology groups, which focus on some of the initiatives around SDN and NFV. So this session, I think, all around the morning we had very good sessions which gives deep insight into the technologies that are there as part of the DPDK toolkit. This session is slightly different. It's in a way it's a gratitude to the community that using the DPDK we were able to develop a virtual network packet broker in in about four months time. And if a technology like DPDK was not there, this would not have been possible. So in a way, it's a gratitude to the community. So with that, I'll start the session. So I think they are quite colorful slides compared to what we had since morning. So we'll cover the business need of a virtual network packet broker. The slightly detailed technical requirements on how the application would be, a very high level architecture, packet processing blocks, some of the challenges that we faced, and certain accomplishments that we were able to achieve with this. So I'm assuming most of this crowd will be familiar with network packet broker. So so that basically will are used to give better analysis on the network and visibility into the kind of quality of service that the network is offering, as well as some of the security aspects and performance on how the applications either in a web scale or in a data center is doing well. But so a typical physical network packet broker will be able to give all this information. But there are certain limitations which the physical network packet broker may have, and that is where there is a need for a virtual network packet broker. So the first is reactive to the programming or reprogramming of network flows, especially in the east-west directions, and especially in the case where the traffic actually does not exit a rack. I mean, it's within the flow is within the rack. And the second thing is basically having orchestration which is run through the analytics information that is available as part of the metrics of the network. So the requirement of this particular solution was to develop a virtual network packet broker which will support some of these features. Now this is not a packet processing pipeline, so ignore the links, but we'll focus on the blocks. So this requires the time stamping and port stamping, filtering, because there would be only few flows which would be of interest, others need to be ignored. NCAP and DCAP, especially when you have VXLAN or NVGRE flows. Load balancing, because in a typical monitoring system, you would have different tools which would be analyzing the packets, and you want to basically load balance the flows not to overwhelm any one particular instance of the tool. Manageability, both in the classical way, I mean, i.e. through an EMS NMS system, as well as through things like an SDN controller. And so for that, basically, we also require open flow support into that. So this basically is a very high level architecture of how the network packet broker was. So the block DPDK based forwarding agent, that is what I mean we developed as part of the solution, and also certain the management interfaces. So we did foresee certain challenges and factored it into our plan. The first one was basically how you handle the management traffic. So there were certain the messages, whether it is the OM message or CLI, netconf, those kind of messages that were we chose to use the standard Linux IP stack because there was no special processing required for that. And the other type of messages were like the ARP or the ICMP messages that are coming from the elements which are being monitored, whether it could be a path-MTU discovery message or that kind of message through ICMP. So to handle those messages, we we foresee that that the processing of those messages would be required and should not be starved off while trying to do the other line-rate processing. So we created a separate queue for that. The other challenge was lack of support for jumbo frames for the tools that basically do the analysis. So that basically was informed by our customer that not all of the tool set will support jumbo frames, and for that reason basically we had to build in the fragmentation processing on the egress side when the captured traffic is sent to those tools. So this is the the pipeline. So we have the pre-ACL where we filter some of the traffic that is of not of interest. Then ARP and ICMP processing, de-encapsulation, and this was a cyclical loop. So till the time you reach the innermost packet, we would go on doing the de-encapsulation and reassembly, and then post reassembly, again a post ACL was applied. Towards the egress side, we would subject this to the load balancer. So that will basically decide what would be the the actual endpoint to which the captured packet would be sent, and based on that information, encapsulation would be done if required, IP fragmentation, and the egress block also had ARP and ICMP, so that when the tool set is probing any information, then this could respond with that. So some of the challenges we had not foreseen. The first one was the packet burst issue. So when there was a burst of packet that would coming, we were seeing that there was either a packet drops or RX errors. So for that reason, dynamic learning of packet burst was threshold was implemented actually to manage the latency as well as the RX error issues. The other problem was the Ethernet state issues. So again, when there were burst errors, some of the packets were silently dropped, and that resulted in mismatch of the aggregation of statistics. And so at that point of time, we could not find a solution in the framework itself. So considering the timelines, we took an overhead in the application where we started maintaining local stats, because the count of the statistics was very important considering the business case of our customer. So yeah, the accomplishment was we were able to deliver this virtual network packet broker, and the highlight was we achieved a relative throughput performance of 80%. So there are different configurations, and we benchmarked the NPB application against a vanilla L2 forward application of DPDK, and we saw that the performance after including the the network packet broker forwarding components was approximately 80% of what we would have got if we just did simple L2 forwarding. So this was deemed good enough, and we are basically now engaging with the customer to have the latest version of DPDK integrated and utilize some of the newer techniques to kind of further enhance the product and the performance. Okay, I think so. That's it's a very really lightning talk, and I hope I was able to convey the thoughts. But in case if you have any questions or suggestions, any inputs, you can send them to dpdk@happiestminds.com, and would be happy to learn from them or answer to the queries. And thanks once again to the community. A lion's share of the success of this project goes to the community, so thank you for that.